code is where we left it last time. I'm stepping back in, so if you have finished the code that we built last time here, you can start from here. You can actually start from the code that is in the zip file in phase 1 if you want to. We have an inheritance hierarchy. So we had inheritance example here. We had the customer class, we had the guest class, we had the person class. The person class was up top. The guest was blank inside of there, and then the customer was down below. And then employee too. We had the employee inside of there that extended out. So we had implemented toString. And notice we just talked about overriding, and you may or may not remember this @ override that was inside of here. That's what overriding comes from. This is a special marker in Java that's saying, by the way, I am planning to change a method that already exists out there. Now, this is not required. I can take overriding out here, and nothing would change in my behavior. It's fine. Nothing's different inside of there. What overriding does is it helps me double check my code that, let's say I said toString and I could say int count inside of here. Just add a parameter inside of there. Well, all of a sudden this override tag, and this is meta information about the code, it gives me a compiler error. It says, hey, this does not actually override something anymore. The toString method does not have a integer parameter that goes inside of it, so you're not overriding. It's supposed to be blank parameters, and then you are overriding again. So it's a nice little reminder. If I don't put the override tag there, it still would override if it legally does so. But if you don't override and you intended to, then it just has this method that nobody uses, nobody calls, and you wasted time in writing. So that's the advantage of this override tag. Now, we saw toString in action before. You remember, we go and run our code. We have the person class, we have some data from the person class, and then we had each of the ones being put underneath that. So you can see the person class gets printed out, the customer class gets printed out, the employee class gets printed out, based off of the one that was called. So if you look at our inheritance example from before, we had created an instance of a customer, we had created an instance of a guest, we created an instance of an employee, and each of them printed out differently based off of which one was called. So when I go to the first one here, C customer, and say print this guy out, it went to the method here for toString for customer, and it printed out first name, last name, username, IP address. Gave me all that information. When it went to the second one, G guest, it went to the guest class and said it's empty, so it did nothing, right? Well, no, of course it didn't do nothing there. What it did was it went up to the person class. And in the person class, it called the person implementation, so that's why I got person right here. So I don't have to override something if there's an implementation out there somewhere. What I need to do is to be able to find it in the hierarchy and call it appropriately. The employee class then, the third one that came out there, just to finish our there, went to the employee class and went to the employee toString method, and it printed out the employee information. So that's conceptual. I want you to understand conceptual. I want you to understand conceptual in action. And the only way to do that is play with code. And so the types of things that I would be doing inside of here, for me, new coder, new language, trying to understand it, is, for instance, let's come to the person class and say, oops, sorry, accidentally dragged and dropped there. Come to the person class and say, what if I take out the override? Does it still work? Does it all still do the same thing? I run it. Yeah, it still get the IP address here. Let me mess now with what I just did before. I say int count. I am now messing with the overriding. My code, I have no compiler errors from this. I hit run. Notice now it says inheritance example dot guest at 15db9742. It is no longer overriding because I am not overriding anymore. I have the wrong parameter list. Since I have the wrong parameter list, then I get the wrong behavior. Where does this come from? Well, it comes from the object class. Every object has a toString. It has the name of the class, the package, and the name of the class, and then a unique identifier for that object. You see it's the DB instead of there. This is in hex notation. So instead of just 0 through 9 as numbers, then 10, 11, 12, so on and so forth, it goes 0 through 9, A, B, C, D, E, and then F, I think, goes as well. So if we actually run this again, we'll probably end up with a different number. Nope, we end up with the same number. It's pulling out the same unique identifier there because the values are the same. Yep, sometimes you get different identifiers. So this is based off of some identifier for this object, so we can see what this object looks like. If I want to have a toString inside of there, I have to override properly. So I take this back out and say toString. I hit Control Save. I hit Run. It's back again. Again, if I spell it wrong, let's say I did lowercase s inside of here. Everything compiles fine. I run it. It's not overriding. All right, so I can put the capital S back, run it again. Yeah, it's override again. Yay. What if I instead of string, maybe I said to return an int? At that point, oh, well, I cannot override toString to return an int because it's not compatible with string. It's trying to override, but it's not because it's the wrong return type. What we had done when we added the int up here, so we had the wrong name, it thought it was something different. Just because it's the same characters, if they're not capitalized, it's not the same thing. My name's Tony, T-O-N-Y. If you sent an email to T-O-N-I, I might not respond because I might not get the email because it's a different person, right? So that's one effect. When I put a different parameter list inside of there, that's again what we called overloading. I can have more than one method with the same name as long as a different parameter list. The return type is unique to the overriding. It must be a string inside there. I will get an error. And that's why we have the @override annotation. That's what it's called here, an annotation. That will ensure that it stays proper. Again, it doesn't change the behavior of the code at all. It just helps us write our code more appropriately. Now, we haven't had anything new here. This is just understanding what it is. So let's go through and add something new. So let's add a abstract method inside of here. So we'll public. We won't return anything. We will say greet visitor. Okay. Now, if I don't know how I'm going to greet every person, I don't have to provide an implementation here. How do I do that? Well, I do that by creating an abstract method. We're going to talk more about that next week. You're going to be required to make an abstract method next week. If you want to make an abstract method to start with now, you can. Because if there's not a common behavior, there's no reason to put something empty. So I could just say empty and be done. Or what I can do is say, hey, you know what? I'm going to say system.out.println welcome. Thanks for visiting plus number of visits plus times. I can do something like that. Now, I'm not incrementing that number of visits in this case. It's a bit of a useless thing. But I can provide an implementation whatever I want to. I just want you to see here that even though I have an abstract class up top, I can provide concrete implementations. I did it with toString. I did it down here again. It's straightforward, simple that way. I can provide this implementation, and then I can come back over here, and on any of these guys that is a guest, I can call it here. So I can say system.println C. I can say C dot greet visitor, G dot greet visitor, E dot greet visitor. So polymorphism says, as long as the method is realized, as long as it's implemented, then I can call it. I can make that happen. And so I can immediately add it to any of the types here. Notice I have a customer, I have a guest, I have an employee. I can call on any of those that behavior. And so I want to do that. I want to add it for all three of these. I run it, and I have the exact same behavior. They all visited 0 times because I haven't changed that behavior. All right, so take a moment. go back and play with this stuff a little bit. Yeah, I mean, we're not really working on the assignment yet. The assignment's going to be pretty straightforward this week once we have the concepts down. But I want you to play with the idea of overriding. I want you to go to your toString method and break it and fix it again. Something that you know exactly what it's supposed to look like before you go create something that is unique to you and we break it and fix it and stuff like that. We're going to do that next. So play with it there. And then before you finish, when add something new, just add something new. Go to the top class you have out of there and create a method. You can create the exact same method I created here, or you can create a method in your class that's to start with, and then we'll go through and we'll override that next time.